Hello and welcome to my first YouTube video. This is a channel I've titled Brad Teaches CAD. So I've just kind of decided that after using Creo and NX and Solidworks for loads of years that I feel like I should pass on some knowledge. I'm not looking to make any money out of this channel, I just thought it'd be useful because I wish I had this when I was at university, and now in my job, now I've learnt a new CAD package that someone teaching me would be beneficial. So the one I'm going to go through today, just the basics of, is Creo Parametric. I've got Creo 5 on my computer, but they're all virtually work the same way. From the ones I've used is 2 up till 6 now, I think they're up to 7 as well. But they all work in the same way, and the start is the same and everything else. So hopefully everything I show you in here will be applicable to any CAD video you have, any CAD package you have, sorry. So first thing you do is you open Creo Parametric. It has Model Checker and Simulate, which is the FEA package, and Layout, which is 2D stuff. But for your general 3D modelling, always open Creo Parametric 5. So this is the out-the-box settings for Creo, so how it will come if you download it from the Creo website, or if you have a copy of it some way or another. It'll always start up with these two boxes. That one disappears automatically. And this is sort of like a Creo community news page, which I pretty much always ignore because I don't feel like there's ever anything relevant on it. Right, so this is the main interface for Creo that you'll get as you open it up. You can make some settings for your own personal sort of ribbon, and how you use it, and how you like Creo to run for you. But I'm assuming that this is one of your first times using it, so I will do it as if it's out of the box. So the first thing you want to do is select a working directory. This is where all your parts and files and things like that will save. So I've just done a folder in here called Creo, and if you were making a model for a customer or for whatever, you could set yourself up a new folder inside of here, which I'll do now, which I will call Extrudes and Sketches because that's what I'll show today. So there's that folder, and within that folder you click OK, and now it will save all of the parts that you make in this session of Creo before you close the window in that area. This is really important when it comes down to assemblies later, so I'm only going to show you some parts today probably, but when you come to build assemblies it's very beneficial to have all the parts in the same folder, because then when you reload the assembly later down the line, Creo can find all the parts. If it can't find the parts, it'll give you a big red box in the model tree, which will be in here, and it won't load up your assembly properly. So now we've done that, first thing to do to make a 3D model, new, and then it gives you this lovely box here. There are different ways of modelling in Creo. I'm going to show you some solids today, but you can also do sheet metal and bulk. Sheet metal is quite a handy function in Creo. Some packages have it as like an add-on in the ribbon when you start drawing, but Creo has it as a sort of separate folder. Right. So you could do a 2D sketch, which we will do within a part anyway, but you can do a 2D sketch. Part is a 3D model, and assembly is a lot of parts put together. Manufacturing is, there is a CAD CAM package in Creo, so if you want to run machine passes and tooling and things like that, you can do that in there. Drawing is how to make an engineering drawing from a part or an assembly that you've made. And format is, you can set the format for your drawings. So when I was working for another company, we did a drawing format, so the company logo in the bottom left and sort of the general tolerances and things that you work to within that company. So what we're going to do today though is a 3D part. So you can give your part a name, so I will just call this Extrude Demo. I can't use spaces in file names for Creo, so I always put underscores in. It just won't let you do it if you have a space in it, or just when you click OK, it'll just say there's an error. The next thing to do, if you are anywhere that's not America, I think now, always untick Use Default Template. Use Default Template will load in the Creo standard format that it has out of the box, which is in inches, pounds and seconds, and obviously if you work anywhere bar America or in international standard units, you need to work in millimeters and kilograms, so we always untick that and it'll give you this. So this is your new file options. Because you untick Default Template, it gives you this box. As you can tell out of the box, it works in inch, pounds, seconds, which we do not want to do. So we select the SI version of that, so it's millimeters, newtons, seconds. Underscore part, because we're going to make a part. Underscore solid, because it's going to be a solid model. You can use some of the other parts as well. You can do millimeters, kilograms, seconds as a solid part as well, but it's just preference at that point. So you can do a description and who it's modelled by. I never tend to, because you can add that into the drawing later on. But if you work for a company that wants traceability, you can add that in. Sorry for the Java window. Right, and then hit OK. And this is your bog standard, how Creo is when you start a new part. So in the top ribbon here you have all of your features, so you can create a new plane. There are 3 standard planes, your X, Y and Z, that all cross through 0, 0, 0 in there. You could add a new plane in so you can offset it, so if you know you want your drawing to start somewhere else and extrude through it, you can do it that way. So that's what the plane function will do, and you can set planes at angles. If you want 45 degrees between that plane and that plane, like a bisector, you can have that one. And it's useful, I'll come on to that later. Axes, so if you want to put an axis inside of a hole or something like that, if you've loaded in a part and you want to add an axis to it, you can do that. Points for sketching, and you can add a coordinate system so you can redatum your models later down the line if you want to. Then there is the sketch feature, which is what you'll use to create your 3D part. So you'll sketch on a 2D plane, and then you'll use one of the shape functions to either revolve it around an axis, extrude it out as a block, sweep it so you can make tubes, and same with blends there, you can have complex sweeps that aren't just a straight line. And there's more in here as well, you can do blend and rotational blend, but we'll keep it very simple for this first one. So that's the sketch function and the shape function, and then once you've done that, you can start adding engineering tools like rounds, chamfers and holes and things into your part, and patterns, but we'll get to that later. So the first thing to note is it will give you your parts. This is sort of the top level save file. Within that part, it builds down from here. So within your part, you've got a right hand plane, which is this one, top plane, which is that one, and a front plane, which is that one. It doesn't particularly matter which one you sketch on, but when you create your model, it will give you, if you click ISO view, it will give you the view from sort of this angle here, which is what we were looking for. So we will sketch on the front plane. So if you select the plane first and hit sketch, it'll automatically do it. If you hit sketch first, it'll ask you to select a plane, so it doesn't matter which way around you do it. That was just out of habit. As you can see, it's given me some axes to draw on that go through 0, 0, 0. To line them up, there's a feature in here called sketch view. I always call it the J magnet because it looks like a magnet and a J, although that is just showing you the flat plane up from the solid model. If you hit that, it'll orientate so you are perpendicular to your sketch. Now that we've entered a sketch, we've come away from the model tab and we're in, it opens up the sketch tab. So in here you can do lots of things. Again, you can put a center line in, points, or a new coordinate system. Construction mode will put lines in that won't affect the drawing. So for example, if I do a rectangle, a really simple one, I'll come into the more advanced feature of this later. You could then do a construction mode rectangle in there. These lines will be dotted and dashed. This will not affect the extrude that we'll do afterwards. That's just an example of what that would do. So you can do it like that, and if you sketch out and then highlight it, we can delete that because we don't need this. Right, the next thing to show you is line. So unlike some other programs, like I use NX on a regular basis now, but line will always work as a line chain. So from when you click left click, it will draw for the next point of a line. So you can just sketch yourself a box like this. Again, I've paid no attention to the geometry there, but that should now create me a solid box. So that's the line function. The rectangle function, there are 4 ways of doing a rectangle, which is different to other programs. NX only has the corner and the center, but with Creo it likes to do slanted and parallelograms. So a corner rectangle, where you left click first, will be your starting corner, and you can drag up and down from there, drag to the other corner. One thing I tend to note about Creo is after you've drawn the part, you can then add the dimensions in. So whatever size I want, if I wanted a 50 by 50, I can draw the box like that. So it'll kind of it'll sort of do your dimensions post your sketch, which means you can draw your rough outline and then add dimensions in later. Right, that is the corner to corner rectangle, and then we have a center rectangle, so you can select a center point. So if I select the point on this axis and then drag outwards, so it builds you a box from that point. And again, once you click left click, it will add in the dimensions. So we'll just drag and delete that one. Slanted rectangles work in the same way. So you select your effectively your axis that you want to work on, so anywhere 0 to 90, and well, anywhere between 0 and 360, and then you drag the rectangle out from there. This can be useful, but I tend to sort of sketch these parts in after I've drawn the original features, but again, different strokes for different folks. And exactly the same with the parallelogram. It works in a similar way to the slanted rectangle, but obviously produces a parallelogram. Right, so that's the rectangle function. Circle, center and a point, much the same way as the second function on the rectangle. So select your starting point, drag out a radius. Concentric, you need 3 points to do a concentric one, so I will demonstrate that using a rectangle. So if I do a center rectangle, come in and add in the geometry, so if I do 50 by 50, and then use this concentric form of the circle, the 3 points of the circle, you could select the 3 outlines and it will draw a circle that's got a 50 radius. Using the concentric here, you can then draw other circles based on that circle. So for the concentric function, you need a starter circle, but other than that, you can sketch as many as you want. And the 3 tangent you can do with 3 lines. So if I have sort of a triangle, I'll demonstrate using the palette. If you have a 3-sided triangle, you drag in here, set a radius of 50. Just using 50 because it's convenient for this, and then do tangent circle. It'll draw the circle like that, exactly the same as the other ones. This one won't be 50, it will be slightly smaller because of the tapering lines from the triangle. There you go, 28.87, so it will call out the geometry that you have. You can delete that and end up with your circle there. So we'll delete those. So again, that's the circle function. Arc, you can just do a section of a circle. So you can almost effectively set for semicircles with whatever radius you want on the side of them and whatever angle you like. So simple function is the arc function. Center and rad, so if you have a center point that you've already defined, and then do, sorry, wrong button, center and rad, you can set the center and then drag it out and select how much of the circle you want to fill in with your arrow. So you could do a quarter segment, a semicircle, or you can go all the way around to near enough a full circle. I think you'll actually get to like 359 degrees before it snaps away. But yeah, that's the center and arcs. 3 tangent works in the same way as before, so if you've got a triangle, you can create a bisector from that triangle. Concentric again, if you have a starter arc like I did there, you can then start building concentric circles out from there, like that. Again, just all very simple but useful drawing things you have in there for your sketching. And then conic, you can do it along a line. So if I sketch a line in, come out of that, and then use the arc function, you could select end and end, and then drag yourself an arc like that. Quite useful for creating some slightly complex geometry. Spline will connect any points together that you choose, and it will start to build you a curve around there. So if you have like a point cloud for all the information for a sketch, you can sort of spline them all together. Create some very funky shapes for spline. Start of your surfacing equipment and that. Fillet will just join, so if you have, for example, a rectangle, you can use fillet to make your corners rounded like that. And then obviously once you've done that, you can set all the rads the same, so it's a rounded section. So if I wanted 25 on all corners, it'll do it like that. Sometimes Creo puts the geometry in weird places for you to constrain, but as long as you can find it and you can add it. Now that's a fairly concentric thing. Obviously I didn't constrain the square when I first made it. But yeah, that's your fillet function. There are other things in there, so you can do a circular trim, elliptical, so you can control it slightly differently, but they're just all controls for that. And same for the chamfer. So if you want to chamfer a corner of a piece, if you're going to be making a bolt, for example, you can use the chamfer tool in the sketch, or you can do it later on in the 3D part. And then you have offset and thicken, so you could offset one box from another if you did 2 rectangles, or thicken, you could make one wider and smaller, so that's just some of those functions. And again, same as before, centerline, point and coordinate systems. One thing that I find useful in Creo that some other programs don't have is the palette function, so within here you've got loads of your basic shapes that you can just add in up to, so yeah, for any polygon from 3 to 20 sides. And then once you load it in, it'll ask you to sort of define the geometry, so your radiuses and things like that. And then your side lengths for your triangles. You can do profiles as well, so if you're drawing sort of RSJs and I-beams, that one's useful. And your general sort of off-the-shelf bar that you can buy from sort of metal stockists, so that's quite a useful function. Then you have your other shapes that are quite commonly used. You can draw any of these shapes with a sketch, but obviously Creo has them preloaded in the sketch palette, which is quite useful. And then stars, which are always quite complex to draw. You can have these in from your own areas like that, and it will draw your stars. You can then change this geometry however you like once you've accepted it. Right, so that's the basic sketch functions that you have within here. I'll show you the constraints once we've drawn something else. So I will go back to reorienting my sketch, and then we'll go ahead and start drawing. So we will do a center rectangle to start with. We'll go back to the XYZ start point, which it should snap to, which is not for some reason. just start the sketch again, just so we can get our axes back where we want them. So the first thing we'll start sketching is a rectangle. I will set the geometries here to 200 by 200, just to give me a nice square. Right, and then we'll accept that sketch with the OK button and left click. We could extrude this straight away, but what I'll do is I'll show you some more sketch functions actually. So within here you've got your editing, so you can delete certain segments. So the delete function works as a drag and carry, so if I wanted to delete just this edge there, I can drag that over there and drag that there, and that's now deleted the line from here. It did this section first and then that section there. Because of this axes up there, it only deleted in halves, but I want to keep that for my drawing. Modify will allow you to change sort of values and the geometry of certain stuff. Mirror will obviously mirror. If I selected all of this, it would mirror it if I set a center line down there, which I'll show you. So I can mirror it through that plane there. So if I needed two that I know a certain distance apart, I can mirror. Divide will split a line into two with a point, so if I wanted to put one there, it will now make those two separate curves with a point in the middle that I can snap to. Corner will ensure that when I drew a square, it wasn't a problem, but sometimes Creo won't pick up that this is a point that's connected, so these lines won't be connected. So if you hit corner and the two lines, it will ensure that there's a point there, and it will create you a solid sketch, which is why it's highlighted in pink. Vertical, so these are constraints for your sketches that you can do. So vertical will ensure that this is a vertical line, as will horizontal. Perpendicular, if you click between two corners, will ensure that that corner is at 90 degrees. This box has come up because I have now too many constraints. Because I drew it as a square, it already had that as a perpendicular corner, so we don't need to worry about that, we can just undo it. What else have we got in here? Tangents, if you're drawing circles and a line off it, you can ensure that the line is a tangent to the circle. Midpoint, so as I did with the other section down there, if I set midpoint there, it'll add a midpoint in that line. Coincident will make sure that, again, if it's not a perpendicular corner, that the 2 points are added together to make sure that it meets at a corner. And then equal, this is quite a handy function, especially if you haven't drawn a square and you want to. If you make the two lines equal and then delete one of the constraints, this will now change both values with one, which is quite a handy function. You have to go back into the select tool to do that, but if I now set this to 250, the other corner will move with it. So it's just how you constrain your sketch will make sure that everything else works together, and then you can obviously set symmetry through a plane like I did when I mirrored earlier. And that, so, and then if you have geometry that you want to control and you don't have a value for it, you can use the dimension function. So this is obviously already constrained, as by that one. But to use the constrain function, left click what you want, left click what you want to measure it from, and then hit your middle mouse button, and that will give you that value there that you can change. So I've just moved, that was already there, but I've just moved it up. But if I wanted to set it 75 away, because it was originally constrained to the 0, 0, 0, that's the stronger constraint, so it will now push that line further away. But if you were going to mirror, you could set your gap, so half. If you wanted 150 mil there, that would be the right number. And you can do reference dimensions as well, which are not driven, so they won't change anything, but it will just give you an idea of what the value is. Right, if we accept that sketch, we can now move into the extrude tab. So we've done sort of our sketching tab. The nice thing about Creo is you kind of work left to right, so along this ribbon here. So now we've done a sketch, we can extrude it. So this starts creating your solid model from here. So you can now set the thickness of the material that you want. So we have 200 by 200 there, I think it was 250 by the end. If we set 250, we've built a nice little cube. So we accept that, and then we have our 3D model that we can view in all planes, like that. So the extrude function works in two ways. You can either add material, or you can take it away. So that is the extrude function. It's very simple. I'll show you a demo of how to remove material. So when I started sketching for the first time, I selected one of the planes, because we now have a model with faces that we can sketch on. You can sketch onto the faces themselves, and it will pick up. So when you hit sketch, if you don't have a plane selected, you can select one of the faces as opposed to a plane. You can still sketch on the planes, but it's probably easier sometimes to sketch on the face. Again, orient your sketch to where you want it, and then you can start sketching within here. So we'll draw a circle in here, it doesn't matter where because this is just for the demo, but again you can set the distances. So if you had a hole that you know you wanted somewhere sort of say 55 and 55 away from that, and then of 25mm diameter. That will produce that for me. I can now use the extrude function, so I can add the material. So if I wanted to add a shaft to it, I can set the value for that. If you set the value negative from the plane, it will automatically default to removing material, which is quite handy. Some other programs don't do that. And yeah, it will remove the material, so I wanted to take 25mm of a circle out of that, but obviously you can always opt to not take that out. And if you want to add it, if you just flick that bar, this button here, it will reverse the direction, so this now becomes 25mm positive, but in the opposite direction, and this will flip it, so it's reading the other way. And yeah, that's extrude is a very simple function within Creo. Some of the programs like NX have a lot more sort of things you can do with your just extrude button, but Creo kind of has its own menus elsewhere for that kind of stuff. So yeah, that's your basic sort of tools for sketching and extruding a model. So we currently have a block with just a small sort of dowel hole in it. Now that we've kind of extruded something, we can move on to the engineering tab. So rather than show you the whole function first, I'll show you rounds. So you can add rounds to edges. So you always select the edge, and it will automatically apply a radius to it. You can set the radius to whatever you want. So if I know I was going to have this counter something like that, it's not a common shape that you would have, but you can add whatever value you like to this. So I'll just set it at 2mm, and that gives you a nice round on that. And the same applies to the chamfer function. You need to select the edges rather than the faces. So if I select that edge, I can add a chamfer to it. There's options for chamfers, which if you are involved in engineering you'll know. So that's the two distances, that's D1 by D2. You can set an angle and the distances, so 45 and 2 is quite a standard chamfer that you would run. You can select that there. Within the chamfer as well, one of the nice functions of Creo is you can make sets. You can do this in other programs, but if you set a new set, you don't have to have loads of things in your model tree. So you can chamfer all those edges. You could do the whole block if you wanted to within one set, if you didn't want to have lots of parts into your model tree and you knew all the edges were going to be chamfered. So a very simple part of the chamfer tool there. So that's round and chamfer. I'll show you draft now. So draft, if you select a face like that, or a plane in this case, you can select a draft and then you can add a draft angle to it. So this is quite useful if you ever do any casting, because you need to have draft angles on cast pieces to remove them from the mould. So that's quite an extreme draft on that one. But you can have a much smaller draft. And then Creo, yeah, it will always function that the centre bit of the line will fall through 0, 0, 0, so it'll orient your angle from 20 degrees out from there to 20 degrees in from there. And you can lock these parts as well, so it won't change any rounds or anything like that. But that's your draft function. Shell's quite a nice one. Solidworks has shell as quite a nice function as well, but you can shell out a face, so you have this block, or you can shell both sides and make it, if you hold control and select both sides, you can make it a hollow object. Because of the settings in Creo, it will leave the hole and some material around it to ensure that it still exists. So whatever thickness you left with your shell, which is, I didn't really show you that too well. But in the shell function I left a thickness, so if it was 5mm, it leaves 5mm walls all the way around it, so it's good if you're creating box section. And then it will leave a 5mm radius around that circle from the hole that was in there originally. You can add ribs as well, so if I select a face, you can sketch a rib on and then drag it out as well if you wanted to add some strengthening ribs inside of there. Yeah, that's kind of a lot of the engineering tools within this. It's a very simple sketch that I've done at the minute. So, another thing I will show you, generally for engineering common practice would not be to extrude a hole into a material, especially if you're going to have it tapped or a through hole. What you would generally do is sketch on the face. Add a point in where you want your hole, so for example there, and then set the dimensions. So if I make that 50 and that 150, if I knew I wanted a hole in that position due to the top surfaces, I would do that, and then I would use the hole function. It automatically picks up on the sketch that I had last and adds a hole to it, and then you can set the dimensions of your holes from here. So because I've done this post shell, it will cut all the way through. So you can have a clearance hole such as that one, or you can start asking for threaded holes and all sorts of different functions. So in here, yeah, this is what I was looking for. So if you hit the one that looks like a screw, you can set your thread sizes. So you can set an ISO thread size, and then depending on what, now we're in the ISO menu, you drop down will give you anything up to an M68, which is a massive hole. But yeah, it'll automatically put it in and drill and tap. So when you create a drawing of this part later, when you do a hole call out, it will tell you the tap size and the drill size that you want to run through this hole. So it's much easier for anyone that's going to make your parts to use a hole function rather than an extrude and then add threads to it later on. You can also add sort of countersinks and chamfers and things within this area. So for cap heads, if you want them sunk within, if this was a solid part, you use counterbore, and if you're using a countersunk screw, you obviously use countersink. You can set the values for those as well, like that. But again, we're just going to add a through hole in there. So this is called out in within this, but it will also call out within the drawing as well if we went to make a drawing of this part. So yeah, that's your really basic sort of Creo functions and kind of the first step to starting to Creo. So I hope you enjoyed this video, and I'll probably make some more soon about some of the other functions you can do in Creo. I'll do some extrude, some revolves in the next video I think, and then some sort of, I'll show you how to add threads to a material if you're not doing it with the whole function, if you're adding external threads and things like that. But yeah, thank you for watching, and share this and ask any questions in the link below if you want to.